Hi students, welcome to my channel Solutions to You. In this video, let us see the solutions for Plus 2 Physics Unit 2 Book Back 1 Mark questions. The ninth question is, in a large building, there are 15 bulbs of 40 watt, 5 bulbs of 100 watt, 5 fans of 80 watt and 1 heater of 1 kilowatt are connected. The voltage of electric mains is 220 volts. The minimum capacity of the main fuse of the building will be. So, you will find the capacity of the minimum capacity of the main fuse. So, generally, you have seen fuse used in electric devices. They are connected in series to protect the device from excess current. It is to protect the device from excess current. Also in building they are used. So we have practically seen in our house and all, sometimes the fuse blow when there is excess current in the circuit. So first we'll calculate the total power. So first it is 15 bulb of 400 watt. This is equal to 600. Then 5 bulb of 100 watt. So this is equal to 500. And 5 fan of 80 watt into 400. And 1 heater of 1 kilowatt. So 1 into it is 1000 watt. So it is equal to 1000 watt. So when you are adding, it comes to 2500 watt. So you all know E is equal to V into I. So voltage is equal to, they have given as 220 volts. And the current is P by V, that is equal to 2500 by 220. That comes to 11.36 amps. So from the option given, we have to select the fuse in such a way that is near to this value 11.36. So 12 is the value which is near to 11.38. So you have to choose a fuse. The minimum capacity of the fuse should be 12 amps. Question number 10. There is the current of 1 amp in the circuit shown below. What is the resistance of P? So there are 3 resistances in the circuit, R1, R2, we will take it as R3. So we have to find R3. So these 3 R1, R2 and R3 are connected in series. So the equivalent resistance is given by R1 plus R2 plus R3. So this is equal to 3 plus 2.5 plus R3. So the equivalent resistance is equal to 5.5 plus R3. Now you all know, as per Ohm's law, V is equal to IR. So here the equivalent resistance is used. So V is 9. The current is 1 amp into 5.5 plus R3. So R3 is equal to 9 minus 5.5. That is equal to 3.5 ohms. So the resistance of P is 3.5 ohms. The correct option is C. Question number 11. What is the current out of the battery? So in the circuit we have to find the current out of the battery. Battery is 5 volt. So here there are 3 resistances and they are connected in parallel. So the equivalent resistance first you have to find. 1 by Rp is equal to, this you take as R1, R2, R3. So it will be 1 by R1 plus 1 by R2 plus 1 by R3. So equal to 1 by 15 plus 1 by 15 plus 1 by 15, that is equal to 3 by 15 and 1 by 5. So the equivalent resistance is equal to 5. You all know V is equal to IR. So you have to find the current out of the battery. So this is the equivalent resistance you have to use. So current is equal to V by resistance. So 5 by 5, that is equal to 1 amp. So the correct option is A. Question number 12. The temperature coefficient of resistance of a wire is 0.00125 per degree Celsius. At 300 Kelvin, its resistance is 1 ohms. The resistance of the wire will be 2 ohms at. So we have to find the resistance of the wire at 2 ohms. The formula for the temperature dependence of resistance is given as R T is equal to, that is a general equation, it is 1 plus alpha into T minus T naught. And usually the R naught is the reference resistance at temperature T naught, and usually T naught is taken as 0 degree Celsius and R naught is the corresponding resistance. So here in the question, the value of resistance is given at 300 Kelvin. So let us take this value as R1. R1 as 1 ohm at temperature T1 is equal to 300 Kelvin, that is equal to 300 minus 273 equal to 27 degree Celsius. This is T1. And the next resistance is 2 ohms. And the corresponding temperature is not known. So we have to find that. So from this general equation, we have to frame two equations, like R1 is equal to R0 into 1 plus alpha into T1. Here T0 is equal to 0. So this is 1. And the second equation is R2 is equal to R0 into 1 plus alpha T2. So substituting the values, R1 is equal to 1. That is equal to R0 into 1 plus alpha. The value of alpha is given as 0.00125 per degree Celsius. So substituting that value, 0.00125 into T1 is 27. So this is equation 1. And the second one is R2 is 2 ohms. So 2 is equal to R0 into 1 plus again alpha 0.00125 into T2 is the unknown. So this is second equation. Now 1 divided by 2 is equal to 1 by 2 is equal to R0 into this 1 plus this becomes 1.03375 divided by R0 into 1 plus 0.00125 into T2. So this get cancelled and you can write as this. So 1 cross multiplying 1 plus 0.00125 T2 is equal to 2.0675, and from this we get 0.00125 T2 is equal to 1.0675, and from this when you calculate the value, T2 is come as 854 degree Celsius, and the answers are given in Kelvin. So when you are converting it into Kelvin, 854 plus 273, it comes around 1127 Kelvin. So the correct option is D. 1127 Kelvin. Question number 13. The internal resistance of a 2.1 volt cell which gives a current of 0.2 amps through a resistance of 10 ohms is. So we have to find the internal resistance, and the formula for internal resistance R is given as the EMF of the cell, that is psi, that is denoted like this, minus V by I. So this EMF is given, so that is psi is equal to 2.1 volt and V is equal to IR, that is equal to 0.2 into 10, that is equal to 2 volts, and current is 0.2 amp. So substituting the value, we can find the internal resistance, that is equal to 2.1 minus V is equal to 2 divided by 0.2, that is equal to 0.1 by 0.2, that is equal to 0.5 ohms. So the internal resistance is 0.5 ohms. So B is the correct option. Question number 14. A piece of copper and another of germanium are cooled from room temperature to 80 Kelvin. The resistance of. So we have to find what happens to the resistance of copper and germanium when they are cooled. So you all know copper is a metal and germanium is a semiconductor. Germanium, it is semiconductor. So this has positive temperature coefficient of resistance, that is alpha. This has negative temperature coefficient of resistance, negative temperature coefficient of resistance. So that means the resistance in R, that is R, increases with increase in temperature. So here we are cooling it. So what happens? The resistance decreases when cooled, when the piece is cooled in case of metal. Here the opposite happens. Here resistance decreases with increase in temperature. So what will happen here? When we are cooling, the resistance increases when cooled. So we have to choose the correct option. Here for copper, that is the metal, the resistance decreases, and germanium, the resistance increases. The correct option is D. Question number 15. In Joule's heating law, when I and T are constant, and if the H is taken along the y-axis and I square along the x-axis, the graph is. So, as per Joule's heating law, H is equal to I square R into T, where H is the amount of heat generated when current flows through a circuit, I is the current and R resistance, and T is the time of flow of current. So in the question is given I and T are constant. So H here varies with resistance. But they have asked the graph for which is taken along y-axis and I square is taken along x-axis. I is constant, it is given, therefore I square is also a constant, and the graph will be I square is constant, it will be like this. So it is a straight line. Graph is a straight line. So the option is A.